Hello everyone, my name's Adam. And in this problem, we're going to be practicing using our fundamental trig identities to simplify trigonometric expressions. So we're going to start with the trigonometric expression tangent theta times cotangent theta divided by secant theta. Now with this one, there's going to be a few different ways to do it. And as you practice more of these, you're going to see that that's going to be the common case in most of these problems. There's not just one way to do it. So since this one won't take a lot of time, we'll show you all three. So what we have is tangent theta times cotangent theta over secant theta. And as we said, we're going to be using our fundamental trig identities to try and simplify this. And now by simplify, we mean the same thing we do in algebra, getting things to cancel, factor, or subtract or add if we can. So here we have everything being either multiplied in the numerator or divided by secant theta in the denominator. So what we know is that tangent and cotangent are reciprocals of one another. So we'll start with that. I know that tangent theta is equal to 1 over cotangent theta. So using that identity, keeping everything else the same for the moment, I can write tangent as 1 over cotangent theta times cotangent theta over secant theta. And so what we see is that our cotangent and cotangent in this denominator will cancel, leaving us with, say, 1 over secant theta. And then lastly, what is 1 over secant theta equal to? Well, we know that cosine theta is equal to 1 over secant theta. So 1 over secant theta is cosine theta. Okay. So we've taken the expression from tangent theta times cotangent theta divided by secant theta all the way down to equal to cosine theta. Now, like I said, there's more than one way to do this. So let's take a look at that. So starting from the beginning, we have tangent theta times cotangent theta divided by secant theta. And like we said, tangents and cotangents are reciprocals of one another. So we very easily could have done a very similar process here. Instead of taking tangent, we'll take cotangent theta, which is equal to 1 over tangent theta. So doing a similar substitution, we're going to have tangent theta times, instead of cotangent, we'll write that as 1 over tangent theta divided by secant theta. And so what happens, we see that our tangents this time are going to cancel. And so that gives us, similar to what we had previously, 1 over secant theta, which again we know is equal to cosine theta. And that's simplified as far as we can go there, getting the same expression. And lastly, we said there were three ways So let's take a look at this one more time. Tangent theta times cotangent theta over secant theta. Now, one thing that we can do, in particular, again, when you get more practice with these, you'll see this, is when you have trig functions being multiplied or divided, one of the fallback methods is to turn everything into sines and cosines and see what will cancel out from there. So we're going to use the fact that tangent theta is equal to sine theta over cosine theta. And cotangent theta is equal to cosine theta divided by sine theta. So using both of those in our numerator, well, we can write tangent theta as sine theta over cosine theta times cotangent theta, which is cosine theta, over sine theta, and that's still all divided by secant of theta. Of course, what we see here is multiplying these two fractions in the numerator, our cosines will cancel, and our sines will cancel, leaving us with the same expression we've had in the past too, 1 over secant theta, which of course is equal to cosine theta. So there we go. 3 different ways using 3 different substitutions. So thank you very much.